Okay, we're going to do a quick summary of the lesson today. The lesson was about the runner that was running at different rates, and then that runner would exchange a baton and go back the other way. The new runner would go back the other way, and this relay would just keep going back and forth. And this lesson is supposed to help you learn about integers and multiplying. And so our integers are the numbers that are negatives and positives and zero non-fraction numbers. Like, there's a bunch of them, but if I start counting up towards zero, these are the integer numbers and they go on infinitely in both directions. So in this problem, one of the problems we talked about was about a runner. This is our runner, Jesse, and it says Jesse, in the first problem, passes the 0 point running 6 meters per second to the right. And the question is, where will he be in six seconds later? So here he's running, and this is the 0 point, and you want to know where he will be 6 seconds later. So every 6 seconds, he goes 6 meters. So we talked about this in class. You would take his speed, 6 meters per second, and you would multiply that by the number of seconds, 6 seconds. S stands for seconds. And when you do that, you get 36 meters. One thing is a little review in your science class. You probably know that the science units cancel out, and if you don't, we'll practice that a little bit later in class time. So what we can conclude is that Jesse would be at the 36 meter point right here. So the way you could answer the question would be, he would be 36 meters to the right of 0. Okay. You could also say he's at the point 36 on the number line graph. You should be able to say both. Okay, so if we look at the next problem, Jesse is now going to the left. So we're now looking at this problem here. Jesse's passing the 0 point, running 5 meters per second, so he must have gotten tired. He's slowing down. He's going to the left. And the question is, where will he be 4 seconds later? So on this problem, since he's going to the left, we're going to use a negative integer to indicate direction. So Jesse's speed is 5 meters per second. So he goes 5 meters per second. So we write it like that. And he does that for 4 seconds. But since he's going to the left, we're going to put a negative in front of that 5 meters per second because it's not only showing his speed, but his direction. So negatives for the left. Then we multiply and our seconds cancel out, and we get a negative 20 for our answer. So Jesse would end up being right here. So he would be at the point negative 20, but we would also say Jesse is 20 meters to the left of 0. So in class today, the problems got harder with the wording, so let's look at some samples of those. Now it says Jesse, so now Jesse's over here. He's still slowing down. So Jesse's going to go back now. He passes the 0 point running. Oh, he must be speeding up. I thought he was going to slow down. 6 meters per second to the right. So as he passes that 0 point, the question now is, where was he 3 seconds earlier? So we want to figure out where he was 3 seconds ago. So he's running to the right, so his speed is 6 meters per second. But we want to know where he was 3 seconds ago, so we're going to multiply now by a -3 because that's past time, 3 seconds ago. So we still have seconds canceling, but we have 6 times 3 is 18, but our final answer is -18 because 3 seconds ago, if you look at the picture, he's crossed 0, so before he must have been at -18 on the number line, or 18 meters to the left of 0. We'll do one more example of this type. So now we'll flip it again. Jesse's going back the other way. Now he's going to pass the 0 running point. Whoops, I'm sorry, we're going to redo this. So just another question, same scenario. Jesse passes the 0 running point, running 6 meters per second, still going to the right. But the question is, where will he be 3 seconds later? So I was trying to get you to see the word later has a different result than earlier. So since he's running to the right, his speed is 6 meters per second, and it's positive because it's to the right. And we want to figure out where he will be in the future, so time is positive. So we're going to multiply, and we get a positive 18. So Jesse will be 18 meters to the right of 0. That's what the book problem was trying to communicate today. We ran out of time, so we didn't get to really sum that up very well. So let's just do a little generalization. This is what we ended class with. The book asked you, after studying the race problem, explain what each product means. So if we look on the left-hand side here, let's take a highlighter. Right here, this -5 meters per second, that meant his speed was 5 meters, but he was going to the left. So there's one way we could explain this. This could be speed. We could say that Jesse is running to the left at a rate of 4 meters per second. And then we could also ask, where was he, because of the negative here, 12 seconds earlier. And so we would take the 4 meters per second, the negative, and multiply it by the -12 seconds. And if you look at the number line, if Jesse's running to the left, he's going to be facing this way. As he passes 0, 12 seconds earlier, he would have been to the right, which is why the answer is positive. So 12 times 4 is 48, so he would be at the 48 meter point, or 48 meters to the right of 0. And then this last one, we could think of this as Jesse now going the other direction, going to the right at the same rate. So he would be going this way, and after he And then the negative 12 is saying, where was he? So where was Jesse 12 seconds? But since time is negative, we're going to say earlier. And the question would be, the answer would be 4 times negative 12, which is negative 48, because earlier, if he is really going to the right, he would have been on the left side, he would have been over here. So he would have been 48 meters to the left of 0. Oh no, you guys, that was all on video.
Are you sure?
Yeah.
Do you have to redo the whole thing?
Okay, so let's try to make a generalization. I think that might, there was a little interruption in here. Sorry about that. My daughter came in. Okay, we're going to just try to make some generalizations. If you look over to the left, we were doing a negative 4 times a negative 12. So we got a negative times a negative and ended up with a positive 48. It makes sense when you look at the number line with that runner. But another way to think about it, well, let's look at the other one first, and I'll talk about some ideas. So the second one is 4 times a negative 12. And when we did that one over here, right here, we got a negative 48. So remember, when you multiply, you can switch order around. And what I like to think of is, here are two numbers, 4 and negative 12. Okay, let's look at these two. So one number is negative 12, and the other number is 4. If I multiply these two numbers together, I use a dot for multiplication. I can think of this first as just 12 times 4, and that's 48. And the negative just is the opposite of 48. So when I do a negative times a positive, I always think of the negative number first, negative 12 times 4, and just think of it as the opposite of 12 times 4. So even though the problem up here is written like that, you can rearrange a multiplication and say, that's the same as negative 12 times 4. So that's the opposite of 12 times 4, which is 48. Up here, you can apply that same concept. We have two numbers, negative 4 and negative 12. Now we have two negatives. We could order them however we want. So if we just keep them in that order, we could just first think about 4 times negative 12. That itself is negative 48, because we just figured that out over here. And this is just the opposite of 4 times negative 12, which is, so you have these two negatives, so you can think of this as the opposite of negative 48, which is positive 48. So if we go farther and add one more page in here, if we have a negative 3 times 6, I would just think of this as the opposite of 3 times 6, which is 18. If I have a negative 3 times a negative 6, I would first do this, and I would remember that I could always rearrange. So I do a negative 6 times 3. That's the first part, and I still have this negative in front. So we work in the parentheses first. This is the opposite of 6 times 3, which is the opposite of 18. And now I have the opposite of negative 18, which is positive 18. So in short, we have a negative times a negative, and we end up with a positive. If we have a negative times a positive, we end up with a negative. We're gonna practice this a little bit tomorrow too.